Okay, it's problem 5. Jeremy puts an empty container under a leaking faucet. In the first hour, 3/8 of a quart of water collects. In the second hour, 1/6 quart of water collects. How much water collects in the container in 2 hours? So we asked the question, do we have a total? And the answer here is no, we don't have a total. But what is the total? It's quarts of water in 2 hours. So we're going to say quarts of water, but we know or should know that it's quarts of water in 2 hours. We do not know what that is. Do we have equal units? Are our units equal? Well, let's think of what the units are first of all. In the first hour, 3/8 collects. In the second hour, 1/6 quart of water collects. So our two units are going to be first hour and second hour, and they're unequal. They're not equal. We only have 2 units, so those units are first hour. Let's shorten that up because that's going to be too consuming. So let's call it first H, second H. Okay, do we know what the first H is? Yes, it's 3/8 of a quart. And do we know what the second H is? Yes, we know it's 1/6 of a quart. Okay, so when I'm looking at my dichotomous key, I start to construct my bar model. My bar model on this one's going to be relatively simple. I do not have a total, but my total should be quarts of water, okay, in 2 hours. We have 2 parts. We have the first hour and the second hour. Those are our 2 units. So what hour are our units? Okay, 3/8 for the first hour and 1/6 for the second hour. So I want a first hour and I want a second hour. I'm just not sure which one of those should take a larger amount of space. I need to think now that this is my math. I need to think I need a common denominator to be able to compare them well. So I think of my least common denominator, 8 and 6, and some kids want to jump to 48, but that's not the best denominator to use here. The least common denominator is going to be 24. So I'm going to make that 3/8, 9/24, and I'm going to make 1/6. I'm going to loop there to make that 4/24, and I see that 3/8. All right, that first hour should be a little bit longer than that second. Okay, so the first hour was 3/8 or 9/24 of a quart. The second hour, I gotta make that a little bit better than that. It should be more. I want to come over just a little bit more. Okay, that's the first hour. That was 3/8, which we made equivalent to 9/24. The second hour was 1/6, okay, but we made that into 4/24. So now we have, go back to our dichotomous key. This is our pot foo here. This is our quarts of water per hour. Quarts of water per hour. Quarts of water per hour. Okay, that's our pot foo, our part of the total per unit. Okay, so if I have no total, I go down the side of the dichotomous key that shows me that I don't have a total. I then say, do I have equal parts or unequal parts? Unequal units are equal units, and I say that I have unequal units. So the dichotomous key tells me I should be adding those units. 9/24 plus 4/24 is 13/24. I can't simplify that, but I know that that means 13/24 quarts of water. So my final answer, 13/24 quarts of water. I know some of you could have solved this without a bar model, but the idea is when the problems start to get more complex, this whole system that leads into a bar model gives us a clear picture of the steps, and we have to kind of break it apart step by step. This one was one we probably could have just jumped right into the addition without all the pictures, but you just need to practice this to get better at it, to see how everything gets put together. It's like a puzzle.